All right, so welcome back. Here we can see that we got all three examples shown in these problems I asked you to do. First one had two answers, -5 and 5. Second one had no solution because we were trying to take the square root of a negative number. And then the final one had x equals 0, which is only one solution because taking the square root of 0 only gives us one answer. Okay, let's move on to the next point. So let's talk about what happens if I have to take the square root early. So sometimes we don't get down to the x squared, but we actually have something else that we have to take the square root of. Let me show you an example. So we'll say example D, okay? So we've got x minus 1 squared is equal to 25. So note here that we already have a perfect square that we're looking at, and instead of trying to FOIL this and get something kind of crazy looking, we can actually just take the square root right now, because notice that the square is on the outside. So if you can take the square root right now, that's what we're going to do. So we take the square root of both sides, and we end up with, on this side, x minus 1 all by itself. Because note, these two things cancel each other out. Is equal to, and now I need my two answers, right? So now I need -5 as an answer, or x, ignore that part, x minus 1 is equal to +5. Now some of you might ask the question, wait, how come I always take the negative and positive answer on this side, but I'm not really doing that with the left side? Well, that's because if you're taking the negative and positive answer on one side, you don't have to do it with the other side, because it would be redundant. If I take the negative answer here and the negative answer here, believe it or not, that's actually the same thing as what I've already done over here. Because if you divide away the negatives, then you just get these answers. So if that doesn't make sense to you, you're just going to have to trust me. You only have to take the negative and positive answer from one side, or else you end up doing something really redundant if you do all the different combinations. Okay, let's move on. So next, we're going to go ahead and solve for both of them, because notice that neither one of these is solved all the way through yet. So I get x is equal to -4, or on this side, we add 1, and we actually get x is equal to 6. So now I've got two answers, and notice this is kind of where we see that our answers are not always going to be just the negative and positive version of each other. This is how we can get two different types of answers, -4 and 6. Okay, let's talk about what happens when you're trying to take when you're trying to take a square root of a number that's not a perfect square. Because that's going to come up every once in a while. If you're trying to solve by square roots, sometimes you just don't get a perfect square. In fact, most of the time you don't really get a perfect square. So let's look at an example. So if I've got x plus 3 squared, and let's set that equal to, I don't know, I'm going to pick a random number. I'm trying to pick a number that's not going to simplify either. Let's take 26. So notice I picked a number that is close to 25, but it's not a perfect square. So when I go to take the square root of this one, there's something I have to do. Instead of giving a negative and a positive answer without the square root, I actually have to keep the square root. Now, this is where that note from earlier comes into play. You know how we talked about how you have a negative and a positive sign, or sorry, a positive and a negative sign on the outside? This is where you actually have to write that in. So these go away. And I'm left with x plus 3 is equal to the negative version of 26, or x plus 3 is equal to the positive answer to the square root of 26. So this is the best way that we can write this, because we don't know what the square root of 26 is. In fact, if you were to punch it into your calculator, you'd get a really crazy decimal. So we're just going to avoid that altogether, and we're going to leave it in its simplest form, which is what you're looking at right here. Now, when we go to actually solve this, we have to keep this intact, okay? So if I do minus 3 to both sides, minus 3 to both sides, what I have to do is I have to kind of rewrite this on the page right now. Instead of writing the negative answer to the square root of 26, minus 3 is my answer here, I'm actually going to put the minus 3 first, because if I do it in this order, then it can kind of look like the negative 3 or the minus 3 is inside the square root. So we want to keep these numbers that aren't in square roots in front. That's kind of the order that looks the nicest and is the easiest to interpret, basically. So these go away. I'm left with x is equal to, and now we're going to rewrite this as negative 3 minus the square root of 26 is how we're going to write that. Okay? And that's how you write that answer. The next answer we write as x is equal to negative 3 plus the square root of 26. Now, something I want you to notice is, since these two answers are so similar, that the only difference is one example you're adding, the other one you're subtracting. What I'm going to do is I'm going to show you another way that you can write the answer. If you want to save ink or pencil lead, whatever you want to say, you just have x is equal to negative 3 plus or minus the square root of 26. This is actually, in math, this is the best way to write this. This is the cleanest way to write it. It's the most efficient way. The reader already knows that they have to do two different things to get two different answers here. So you're actually telling the reader that there's two answers to this problem, even though you've only written one equal sign here. So either option, you can either write this or you can write this right here. Either way, you're writing the correct answer. Okay, let's go ahead and do some examples from the book, or some problems. So we're going to do page 465, numbers 4 through 6, all. Okay, so I'm going to let you do that and we'll come back. I have one more video for you.